identifying what kind of variation an equation has, or a set of points have, based on just the appearance of the relationship between the points of the equation. And then we're also going to work with these three different types of variation to help us solve. So those are our learning targets for today. So I'll be checking in with you guys on those when we get to the end. So the first type of variation we're going to talk about, the first type of variation is direct variation, which looks like this. There we go. That equation right there represents a direct variation relationship. Some other terminology you guys might hear is directly proportional or directly varying. They could use the vary or the proportional interchangeably. They mean the same thing. So when you guys see that kind of language or this kind of language, they're talking about this relationship that is represented here. Now, the relationship that's going on here, the operation that we're using that's connecting the k to the x is multiplication. The reason why I'm pointing that out is because we're going to have another one that has division, and it's very important you guys know the difference. Now, we have the y and the x. Those are the two variables that are related to each other. This k is called the constant of variation. It's important you guys know what the k is called. Okay? So the constant of variation is represented by a k, and the k is going to tell you the specific relationship between the two variables. Okay? So I like to call this, if I don't know any numbers, I call this the skeleton equation. This is kind of where we just kind of set the stage here. But whenever you guys are writing an equation to relate the y and the x or whatever variables, you always need to find k as a number and then plug it in. So this is where it starts, but this should never be your final answer. Okay? All right, so let's jump right in. The kind of questions you guys might see. This first one says, find the constant of variation, which is, okay, find the constant of variation and the variation equation. So that means after you find k, plug in k to show what the relationship is between the y and the x. If y varies directly as x, and I have this value for y and that value for x. Okay, so I have two things that I'm looking for. I'm looking for the constant of variation, which is k, and I'm looking for the equation, the variation equation between the two variables. Now, an important word to look for, obviously we're in the section that's practicing direct variation, but once we have learned all three, you guys will see the questions kind of jumbled up. So it's important you guys find the word that's either direct, joint, or inverse. It tells you which kind of variation, so I'm going to circle that. Now, underneath the word directly, I'm going to write down the skeleton equation for direct variation using the two variables that we're talking about. Y is over here, so y should be on the left, and x is over here, so x should be on the right. They may use different variables. They could use a and b, they could use c and d, t and s, I don't know. Just know that whatever order they spell them out here, that's the order they should be in the equation. Okay? Now, they have given me the value of y and the value of x. What do you think they want me to do with those? Find the value of k. How many unknowns are in the original equation? 1, 2, 3. So if they give me two of them, what's the only unknown I don't know? K. So the reason why they gave me y and x was to help me answer the first part of the question. Solve for k. So I'm going to do that. I'm going to plug in negative 24 and 4 for y and x, because they told me what they were. And then when I solve for k, what do I get? I get negative 6. So that was the first part of the question. They wanted me to find the constant of variation, which was k. Found it. Awesome. First part done. Now the second part was the variation equation. The variation equation is not this. This is the skeleton equation, that's the foundation for our answer, but you don't actually know what the variation equation is unless you know how they vary. And k tells you how they vary. So if you want to write the variation equation, you're going to have to plug in k to show what the relationship is between the two. This is saying that y is equal to x times negative 6. So when you're writing the variation equation, you have to find k first, then plug it in, and then that's it. Does that make sense? You use this as your foundation, but this should never be an answer to anything, unless I ask what the skeleton equation is for direct variation. Okay? All right, next one. If y varies directly as x, what's the most important word to notice there? I'm going to circle that, and I'm going to write the equation. Y is on the left, x is on the right, so I have those. Then it tells me y is 15 and x is 3. Why did they tell me the y and the x? To help solve for k. They didn't say, this question doesn't say specifically find K, find constant variation, but we need K to move forward. So they may not ask for it directly, but you still need to find it. So I'm going to plug those in. What would the value of K be? 5. I divide by 3, I get K equals 5. Alright, so now that we have that in hand, I want to find y when x is equal to -2. So what I'm going to do is I'm going to rewrite the skeleton equation. This doesn't help me do anything if there are all 3 unknowns. But once I know k, now the equation looks like this. So now all I have to do, if I'm trying to find y, I just plug in x, and then I can find y really easily. So y is equal to 5, because I already found the k, and then I plug in -2 for the x. What would the y value be? So when you guys are doing these questions, you have to know k. Even if the question doesn't specifically ask you to find it, like in the first one, you have to know k. Otherwise, you will not be able to find either of the 2 variables. Because if you don't know k, you're always going to have 2 unknowns. 1 variable and then k that you don't know. You can only solve for a variable if that's the only unknown. Okay, so always find k. Whether they ask for it or not, always find k first. And then plug in the values to find the variable you're looking for. Okay? That's why they give you these numbers in the beginning, so you can find k. That's the whole point of that. Alright, so that's direct variation. Any questions about that? Okay. Now we're going to talk about joint variation. It is a type of direct variation simply because it also involves multiplication. But joint variation is going to have more than 2 quantities that are related. And so it's going to look like this. This is a skeleton equation. You're going to have 1 variable over here on the left, and then your constant variation, and then 2 or more variables on the right that are being multiplied. So again, this is multiplication, and we would say that this is y varying jointly as x and z, or whatever variables you're using. Okay? Now, they don't always have to be in that order. You just need to have 1 over here, and then 2 or more over here. But they could be in a different order. It just depends on the wording. Alright, so I'm going to look over here in the first statement. Y varies jointly with x and z. What's the most important word in there? Jointly. Now I'm going to use the way this is written out to know what the skeleton equation would be. I have y equals kxz. Y is on the left, x and z are on the right. Now it gives me x and it gives me y and it gives me z in the next statement. Why did they give me x, y, and z? To find k. They gave me everything except for k, so therefore I'm going to use those things to find the value of k. So if I plug them in, I have 20, don't know k, x is -2, z is 5. So this becomes -10. I divide over, so what would the value of k be? Okay, so k is equal to -2. Yes?
So they always have to tell us what kind of equation they're asking for, jointly or...
Yeah, they'll always tell you what variation it is. Yeah. Alright, now that I know k, I can keep going. So the first part of the question says, find the equation that relates the variables. So what would I write down as an equation that relates the variables? What would that equation be? What's the variation equation? Y equals yes. It's the skeleton equation for this joint variation, but with k plugged in. Because the k is specific to the scenario. So this is the first part that they wanted. Then it says to find z when x is equal to -3 and y is 60. Now, this has the original skeleton equation has 4 unknowns, but now that we have k, and now that we have x and y, we only have 1 unknown, the z, which is what we're looking for. So that's what we're going to do next. So in the next part of the question, we know that y is 60, we already have k here, the x is -3, what we don't know is z, so that's what we're going to solve for. -2 times -3 is positive 6. We're going to divide the 6 over. What does that leave me for z? 10. So that was a 2-part question, the equation, and then the value of z given to our numbers. Okay? Alright, let's look at the next one. Z varies jointly with x and y. What's the key word there? jointly. Now look very carefully on how this is spelled out. What should be on the left side? Z. What would this be as a simplified fraction? Should be 1 over 12. Should be able to do that in your head. Okay. Again, the question didn't specifically say to find that, but we know that we need k in order to move forward. So, now that I know k, the first part of the question says find the equation that relates the variables. So what would that be? Z equals 1 over 12 times 1. Remember, the variation equation or the equation that relates the variables, whatever terminology they use, if they're asking for an equation with all these variables together, you just have to rewrite the skeleton equation but plug in k, where it goes, as a number. Okay, and then lastly it says find z when x is 10 and y is negative 2. So I'm going to plug in those values. I already know this is 1 over 12, x is 10 and y is negative 2. So that's going to be negative 20 divided by 12. What would that be as a simplified fraction? Or sorry, no, wait. Yes. Write it in there. Negative 5 over 3. Just as a rule of thumb, for variation, let's just keep everything as fractions. Simplified fractions. Alright, so everybody okay with joint variation? Our last type of variation we're going to talk about is inverse variation. So with inverse variation, we're going back to just two variables, and your skeleton equation looks like this. Now with direct variation, we had multiplication. For inverse variation, we have division. So for direct variation, it was k times x. For inverse, it's k divided by x. So it's very important you guys notice the difference. This inverse variation is kind of our doorway into Unit 6, because Unit 6 is all about rational functions, fractions. So this is kind of our baby step into what the entire Unit 6 is going to be about. So we're going to approach this exactly the same way. If y varies inversely as x, y equals k over x is our skeleton equation for that keyword inversely. They're giving me the value of y and x, so I can solve for k. So we have negative 3 and then 4. So to solve for k, I'm going to multiply the 4 over from the denominator. That gives me k is equal to negative 12. Again, the question's not going to prompt you to solve for k. You guys just need to know that if you see I know the y and I know the x, the only thing I don't know is k, so that should be a kind of implication that you guys have to find that. Then the question is asking to find the constant of variation, so we just did that. So we answered the first part of the question here. And the equation relating x and y. So again, when they're looking for that equation that's relating them together, you're just going to rewrite the skeleton equation, but with the value of k plugged in as a number, the value. And then lastly, they want us to find y when x is equal to 6. So very simple, I'm just going to plug in the 6, and I get negative 2. Pretty straightforward stuff. And that one. This next one is the exact same type of question, just with different numbers. So again, if y varies inversely as x, I'm going to write my skeleton equation. I'm going to plug in the value of y and x and solve for k. Remember, you're going to multiply that negative 2 over to get it out of the denominator, so k is equal to negative 20. That was the first part of the question for the constant of variation, which is k. Then they want the equation relating x and y, so that's just our skeleton equation over here in green. Plugging in the value of k, and you got it. They want the specific one, not the general one, the specific one for the scenario, so that's why we plug in the value of k. And then I'm going to find y when x is equal to 4. Just leaves me with negative 5. Right? Pretty straightforward stuff. Right? Alright, the next one we're going to look at this bottom of the page, these are what I call compound variation. So it's going to involve more than one variation in one equation. So if you read the directions for this one up here, it says y varies directly as x and inversely as z squared. So I'm going to have in one equation, don't write two separate ones, in one equation I'm going to have a direct relationship and an inverse relationship at the same time in one equation. So the best way to approach this is to just write the equation for the first variation and then add on the next one. Not with addition, I mean just like build on top of that existing equation to represent the other variation as well. So if I'm just doing y varies directly as x, what would I write? If I was just doing that. Y equals kx. That would represent the directly part. Then it says, and inversely as z squared. How do I build on top of this to get an inverse variation? I already have k, right? This k is going to serve as the k for both the direct and the inverse. So if you kind of just imagine this is the k, what would I build onto that to get inverse? What operation? Divide. So it's like k divided by, and then what should go in the bottom? Inversely as z squared. It may be, the variable may be manipulated, it could be squared, cubed, cube rooted, square rooted, whatever. So just, there could be other things that you do to the variables, but that expression needs to go on the bottom. So this has both direct and inverse involved in its expression here. Alright, so that's the skeleton equation. Now, they're going to tell me that y is equal to 2, x is 5, and z is negative 4. Why did they tell me those three numbers? To find k, just like we have before. So y is equal to 2, x is 5. Now this we have to be really careful. Remember how z is being squared? If z is equal to negative 4, what should go in the denominator? Positive 16. So make sure you remember any of those powers or cube roots or whatever you use them. Sorry, that fraction bar should not go all the way across. Alright, so what I'm going to do to solve for k is I'm going to multiply the 16 over. Gets rid of the denominator, so that would be 32. And then I'm going to divide by 5. So k is going to be equal to 32 over 5 because that cannot be a simplified fraction. It just has to stay the way that it is. Okay? Now, what we're actually after here is to find y. So we're going to find y when x is equal to 7 and z is equal to 12. So, I'm going to plug in what I know. So, I don't know y. K is 32 over 5. X is 7 and z is 12, but remember to square that, so it's really 144. Then to evaluate this, be really careful on your calculator because there's a fraction involved, there's a fraction inside of a fraction. So be really careful. What I would recommend is in your calculator, in parentheses, do 32 divided by 5, enter, times 7, enter, divided by 144, enter. Just do it in pieces. So 32 divided by 5, find that number, multiply that times 7, find that number, then divide that by 144, find that number, and then take that number and turn it into a simplified fraction. As a decimal, it should be like 0.3111111. But as a simplified fraction, what would it be? 14 over 45? There you go. Alright, let's show the next one. Y varies jointly with x and z, but inversely with v. So how would I write the first one? The first relation. Anybody? See people writing, so that means you know it. So you just have to say it. Y equals k x. Nope, I'm not going to multiply. Divide. Says the inversely is division, so underneath all of that you have v in the denominator, so you have the inverse relationship. Alright, so this is my skeleton equation. So now I'm going to solve for k using the information they provide, so I know that y is 10. Don't know k yet. X is 2. Z is 3, and 6. So what happens here is the 2 times 3 in the numerator cancels out with the 6 in the denominator, so that just leaves me with 10. So k is equal to 10 here. And then our mission is to find v, the variable in the denominator. So now that I know k, I know that in this separate question, the last sentence here, y is equal to 2. We already found k is 10, x is 5, c is 1, and what we're looking for is v in the denominator. So whenever you guys are looking for a variable in the denominator, something you guys can do, obviously if you have a denominator, you can move it over here by multiplying. If I multiply the v over, I would then divide by 2, which would essentially just switch those two values. So I'm just going to do that straight away. I know algebraically I can just do this. A variable and a value over here can just switch positions. It's like 2 mathematical steps in one, you can just automatically switch them. So v is over here, 2 goes down here, the top becomes 50. So then what would the value of v turn into? Right, so that's how we use direct, joint, and inverse variation, or a compounding of those to solve. Now, the next learning target you guys need to address is being able to look at an equation or a set of points, which you see at the very bottom, and determine what kind of relationship they have. Do they vary directly, jointly, or inversely? Now, the trick to this is that you have to make sure that it's a variable equal to the other variables. Typically y equals, but not always. But you need it to, you can't have 2 variables over here. It needs to be 1 variable equals and then a number over on this side. The number that I'm giving you is the value of k. Okay? So for this one, it's already set up that way. We have y equals something divided by x. What variation would that be? It's inverse because we have the division here. X is in the denominator. What about the next one? Y equals negative 1.2 times x. That would be direct variation. What about y equals 5 times xz? That would be a joint variation. If you see more than 2 variables, it is automatically a joint variation, regardless of how it's set up. Okay? What about this one? What would I have to do? Move the x to the other side? Okay, now what? What variation would that be? What operation is it using? Subtraction? Which variation uses subtraction? Which one uses subtraction, guys? Does direct use subtraction? Does it? No. Does joint variation use subtraction? Everybody? No. Okay, thank you. One person. Does inverse variation use subtraction? No. Okay, then what kind of variation is this? None. There's always an option for none. So be on the lookout for that as well. What about this next one? What would I have to do? Okay, I mean you could solve for either x or y, but if you want to solve for y, get this, right? You get the same thing if you were to solve for x, it would just be x equals 3.1 divided by y. So regardless, which type of variation would this be? Inverse. Alright, what about this next one? It's joint variation because there is more than one variable. Also, you could rewrite it like this. You could just divide the 2, which is multiplying times 1/2. So you have multiplying times 1/2 with the x and y, so it's a joint variation in terms of z and xy. And then what about this one? What would I have to do first? I would have to multiply the x over, right? And then that becomes multiplication, so I get my direct variations here. Okay, so is everyone able to see? Any addition or subtraction is not a variation. It has to be multiplication or division. Okay? Great. Now we're going to those are both of the learning targets that we've talked about. So that was discerning what type of variation something has, and on the first page that was using variation to solve. Now we're going to repeat those learning targets, but in a slightly different context. We're going to do the solving stuff again, but for more complicated looking word problems. They're going to work the exact same way that we saw on the first page. They're just kind of, you have to use a little bit of context. And then down here, we're also going to do the same kind of thing where we determine what type of variation it is, but off of points instead of an equation or a function. Okay? So up here, we're just going to start by writing equations before we actually start solving them, just so you guys can practice that in this context. So for these three, we're just going to write an equation. Alright, so for each of these we're going to write an equation. So a couple of things you guys want to look out for is, first of all, you guys are going to create the variables yourself. So based off of the values we're working with, like whether it's volume or radius or diameter or something like that, you guys will invent the variables for yourself. Something else you guys want to look for is what kind of variation it is. Is it direct, inverse, or joint? So let's look up here at this first one. The volume of a sphere varies directly with the cube of its radius. What's that word in here that's going to tell us what kind of variation? Directly. Okay. Now, what variable should I use to represent the first value over here? The volume of a sphere. What variable would work best? No. What variable is a common sense representative of volume? V. Don't just do x and y, because you guys are going to get really confused. If you use x to represent something that doesn't even have an x in it, you're going to get really confused on which variable represents what, and you won't know what to plug in numbers for. So always use variables that represent the object you're replacing with the variable. So equals, right, the volume, and then the word directly or varies directly is going to represent where the equal sign goes, and then everything on the other side is going to have the constant of variation multiplied with it, because it's direct variation. So what variable should I use for the cube of its radius? R, and then what am I doing to the R? Cubing it. So I'm going to have k for the constant of variation. K is always k. You don't have to worry about that one. It's the other variables that you're going to pick. And then because it's radius, I'm going to use R for radius, and it's being cubed, so I need to make sure I use the exponent. So you guys will see other words like cubing or squaring or square rooting or 2 times as much or stuff like that. That's just stuff that you would add into the equation based off of the word problem. So this is our first one here. That would be a direct variation. Next one, the intensity of a sound varies inversely with the square of its distance from the source. What's our key word in there? Okay. Now on the left side of the equation, we're going to have intensity of a sound. What variable do you want to use to represent that? Intensity of a sound. I for intensity equals, and then for inverse variation, what operation would I use? It would be k divided by something, because it's inverse, so I set it up this way, and then the square of its distance. What would the term be on the bottom? The square of its distance. D squared. It's the distance, but it's being squared. Okay, so that's our next one. Then the last one says the horsepower for a pump varies jointly with the well depth and the rate of the pump. What's our key word there? Jointly. All right, what should the variable be on the left side? H for horsepower. We have our K, jointly with the well depth, D for depth maybe, multiplication because it's jointly, and then rate of the pump, R. So this is the first skill you guys need to have in order to do these word problems, is to create the equation based off of this statement, the variation description, here in order to create that equation using the best variables possible. So you can actually plug in numbers intelligently. You just use x's and y's and then you forget what x represents and what y represents, you won't be able to put the numbers in correctly. Okay? Alright, so let's jump into these 2 word problems. They are science related. I don't know which science. Probably physics or something. Okay, So this one says, according to Ohm's law, the current flowing in a wire is inversely proportional to the resistance of the wire. That first sentence is going to tell us our equation. Which type of variation? Inverse. On the left side of the equation, what variable should I use? C. C for current, right? Current, and then it's going to vary inversely with the resistance. What variable? R. Okay, now how would I write this part for the inverse? K over R. So this is my skeleton equation right now. Okay? Next sentence. If the current is 5 amps when the resistance is 24 ohms, stop. What does that first part help me do? It gave me current, which is C, and it gave me resistance, which is R. What do I do with that? Find K, which is exactly what we did in the other problems on the first page. So when current is 5, resistance is 24, what's the value of K? 120. Alright, with that under our belts, we're going to keep going. If we know that information, we have K. What will the resistance be when the current is 6 amps? What do they want me to find? Which variable? R. So that means they have to give me the other one, C, which they did here, 6. So no, you can go back to the skeleton equation if you need to. 6 is equal to, I know K is 120, R is what I don't know. And remember, if you guys have something here, you can swap those. So I'm going to swap the 6 and the R. And then 120 divided by 6 is 20. So the answer, if you're including the units, the ohms, that weird symbol thingy, and omega, 20 ohms. Okay? So it's the same structure, same process as what we did on the first page. You just have to pay more attention to what's going on in the word problem to get cues on what to do next. Okay? Next one we have Hooke's law. So Hooke's law says that the force needed to stretch a spring is directly proportional to the length the string is stretched. Direct. What's my variable on the left? F for force. What's my structure for direct variation? What operation would I use? K times something, right? So constant of variation times. Now the other side says it's proportional to the length the string is stretched. So what would it be a nice variable for that? What about the spring? What about the string? Or yeah. Well, sorry. What about the spring is being measured? The length. So use L. So this is my skeleton equation. Next up it says, if 50 pounds of force stretches a spring 5 inches, stop. That just gave me the force and it gave me the length. So what am I expected to do with that information? Find K. So 50 is the force. The length was 5. So what's the constant of variation? 10. Right, now that I know that, keep moving on. If we know that information to help us find K, how much will the string be stretched by a force of 120 pounds? So what are they asking me to find? Which variable? L. So when they said how much will the spring be stretched, it's asking for length. So length, when K we already knew was 10, or we just found that. Force, oops, that's in the wrong position. Force is 120, K is 10, I'm looking for L. So L would be 12 inches. Okay, so again, same process as on the front, you just have to read it a little bit more carefully. This is what. Alright, any questions up till here? Alright, last thing we're going to talk about is how to tell if a set of points represents a direct variation or an inverse variation. You cannot have a joint variation because joint variation needs 3 variables and a point is only in terms of 2. So it's either going to be direct or inverse. The way you're going to do this is you're going to take your points and you're going to plug them into the direct variation skeleton equation and see if each equation will give you the same k. If they don't, then you're going to try that again for the inverse variation. Plug in the y and the x for each point, see if you get the same k for each set of points. If you don't get the same k there as well, that means that they didn't have any or either of the 2 relationships. So you're going to check direct first. If that doesn't work, then check inverse. If that still doesn't work, then it has neither. What you don't want to do is check one of them, and if that doesn't work, assume that it's the other, because it could be neither. Okay, so make sure that you check both. So over here, I'm going to start with direct. So I'm just going to take the x and the y and plug them in. So I'm going to have negative 30 equals k times negative 6. Negative 10 equals k times negative 2. 5 equals k times 1. 10 equals k times 2. I'm literally taking y equals k times x and then plugging in the k and the x from each point and just writing it down. Alright, now once you have these written down in your head, it should be really easy mentally. I'm just going to go through and see what all the k values would be. If I solve for k, if I divide by negative 6, what do I get for k? 5. If I solve for k here, 5, 5, 5. Okay, so if you solve each of those little equations and you get the same k value every single time, that means that this structure works, and that means that it would have direct variation. If you didn't get the same k for each of these equations, you would then Four. Okay, then solve for k here. What's 4 times 1? 4. 2 times 2? 4 thirds times 3? 4. So did the indirect structure give me the same k value? So what does that indicate about this? Inverse. So this one would have inverse variation. Right? For the last couple of minutes, we're going to do this last example really quick. So again, I'm going to check direct. So 1, and then I'm going to do k times 0.5. K times 0.25, k times negative 4, k times 3. Now once you write all of those out, I'm going to go one by one to see if it works. So if I multiply the 0.5 over, get 1 times 0.5 is, or sorry, divide. You divide the 0.5 over. What is 1 divided by 0.5? 2. If I do 2 divided by 0.25, is that 2? No. So that means that direct didn't work. Now we're going to try really quickly for inverse. We're going to do the same thing, but we're going to do division instead of multiplication. Now in this setup, when I multiply to solve for k, what is 1 times 0.5? 0.5. What is 2 times 0.25? Also 0.5, looking good. What about 3 times negative 4? Is that 0.5 just like the other two? Nope. So then if direct didn't work and inverse doesn't work, this one would be neither. Neither direct nor inverse.